Welcome to the People and Planet podcast, a show all about human health, planetary health, and the links between them. I'm your host, Ali Al-Hamed, an integrative nutrition health coach with a master's in environmental sustainability. I spent most of my life exploring these topics, and this podcast is my effort to collect and deliver information from experts to improve the quality of your life and that of our planet. Thank you so much for being here. This podcast is for educational purposes only and should never replace the advice of your doctor or physician. Always consult a medical professional before making any changes or adding anything new to your diet, lifestyle, or medication protocol. If you've been interested in longevity or reversing your age, you've probably come across NAD or NAD+. This molecule is gaining popularity in the health and wellness spaces as a way to slow down the aging process, boost energy, improve cognition, and improve cell damage. Now, why wouldn't that be attractive, right? Well, NAD+ may not be all it's cut out to be. The truth is we simply don't know enough about supplementing with this molecule. The science just isn't there yet. In this episode, I interviewed Dr. Nichola Conlon, who is a scientist and an expert in NAD+ and cellular health. She explains what this molecule is, where the science has reached so far, and what some of the dangers or implications of supplementing with this molecule are. Dr. Nicola's particular focus is on the science of aging well. After a career in drug development, Dr. Nicola founded Nuchido Laboratories, driven by her belief that cutting-edge science should not lie hidden. At Nuchido, she is passionate about translating the latest scientific breakthroughs into products that slow biological aging. Along with leading scientists at Nuchido, Dr. Nicola has identified the right combination of targets to restore cellular NAD+ production back to youthful levels, leading to the development of a breakthrough NAD+ booster called Nuchido Time Plus. Dr. Nicola is on a mission to democratize science and has a passion for translating advanced science in a consumer-friendly manner. She regularly speaks about the science behind the symptoms of common aging complaints, educating and empower people with the latest knowledge to reverse their biological age and improve their health span. I look forward to speaking with her today, and I hope you enjoy this episode. Well, Dr. Nicola, thank you so much for being here and having this conversation with me again. You and I had an amazing conversation a few months ago. We did an Instagram Live together about all things related to longevity and NAD+, and it gained a lot of great attention, and for good reason. Everyone is interested in living healthier, happier, longer lives. And this molecule, NAD+, is making its way in the health and wellness spaces. And it's being known as, or it's promising, the fountain of youth for people who are aging and 30 to 35 years and above. And you yourself are a longevity expert and NAD+ expert and a scientist. So I'm really excited and grateful that you're here again today to share your insights and delve a little bit deeper into the world of NAD+. So thank you again for being here.
Yeah, no, absolutely. Always happy to chat science.
Thank you. Well, so what is NAD+? How do we understand it? What is it? And why is it so popular in the longevity space?
So NAD, I guess, or what I always refer to it as NAD. Sometimes it's called NAD+, sometimes it's called NAD. It has various different names that it's referred to by, but essentially it's a natural molecule. It's found in every single cell in your body, and it actually stands for nicotinamide adenine dinucleotide. So that's why we have all these abbreviations, because it's quite a long name, a long scientific name to remember. But essentially it's found in every single cell in our body, and it's so important in our bodies that if we didn't have it, we'd literally be dead in 30 seconds. And that's because it's performing some really critical functions. The most important one is energy production. So in all of the cells in our body, we have these tiny little energy power plants called our mitochondria. And they are the little factories in our cells that literally take the food that we eat and convert it into all of the energy that our cells need to function to keep us alive. And NAD is a very important molecule that sort of participates in this process in helping to produce our energy. And this is why if we didn't have any NAD in our bodies, we'd literally be dead, because we could not produce any energy to keep our bodies functioning. So that's the most important function of NAD. But the reason why NAD has become so interesting in the longevity space is actually for one of its other functions. And that is because NAD seems to keep a lot of our maintenance and repair processes in our cells switched on. So as a general rule of thumb, if you have high levels of NAD, you will have lots of energy production, but you will also have lots of repair and maintenance in your cells. So your cells will be getting kept in good health. But if NAD goes down, then energy goes down, but also repair goes down. So you start to get an accumulation of damage in our cells. And this is what seems to manifest as the sort of external signs and symptoms of the aging process. And the issue that we have is that although we're born with very high levels of NAD, it actually declines as we get older. And this decline is quite great. So it's estimated that every 20 years, our NAD levels actually halve. So, by when we're born, by the time we're 20, what we had when we were born has halved. By the time we're 40, this is halved again, and so on and so on. And that means that this crucial molecule that's doing all these really important processes in our bodies is just dwindling away to the point where we really don't have very much left at all. And that's quite scary because, as mentioned, it's so important for energy production, and it's also so important for keeping our repair switched on in our cells.
So I guess that's also why people love to supplement or intravenously administer NAD for the youthfulness look it offers us. So when you talk about cell repair and cell health, that's also how it's offering really good skin. People are saying, I'm drinking from the fountain, and that's why it's offering really good skin. I guess my question to you is, what are the different ways to administer NAD+, and how safe is it? And then what are maybe the contraindications and the dangers? What should people know about it when they're going out to their clinics or going to their supplement aisles and seeing it on the shelves? What do people need to know about it before they take it?
Well, I think when it was discovered that, NAD was this important molecule, but it declines with age, scientists kind of said, well, if it's declining, then why don't we just not let it decline? Can we keep NAD levels topped up? Can we keep the levels of NAD in our cells at that useful level that we were born with? And if we can do this, does that mean energy production will stay youthful? Does it mean that repair will stay switched on? And it'll mean that we don't get the levels of cellular damage associated with aging. So this was kind of the vision of why can't we keep it topped up? So there were a lot of experiments done to demonstrate, firstly in cells and animals and humans, to demonstrate that actually you can boost NAD levels. And when you do boost NAD levels, you do actually keep energy production switched on. You keep repair switched on. You keep the cellular health of your body in much better shape for longer. So this has led to a huge rush of, all sorts of people, everything from scientists to companies to, supplement companies, doctors, all looking at how can we boost this NAD in ourselves. And the most obvious thing that was tried first was, well, why don't we just put this pure NAD molecule in some pills and swallow it, and hopefully top our NAD back up. Unfortunately, it was found it wasn't that easy because NAD is a very unstable molecule, which means it breaks down really, really easily outside of our cells and indeed outside of our body. So whilst there are, still some companies that are saying you can put NAD in a pill and sell it on Amazon and take it, this absolutely does not work. There will be no NAD in that pill because it will be degraded. And certainly if there was any NAD, by the time it got through your gut, it would certainly not have any left by the time it had been through the stomach, etc. So this led to people saying, okay, if we can't take this NAD molecule orally because it's unstable, then why don't we inject it? Why don't we do NAD IVs? Is this a way that we can take this unstable molecule, we can mix it up fresh every time and, bypass the gut and just put it straight into the body? And again, this was thought of as a way that could potentially get around some of these other factors. But the issue with this is that NAD is actually a big molecule. So not only is it unstable, which is an issue, but it's a big molecule. And where NAD performs its function is actually inside of the cells where the mitochondria are. So mitochondria do not exist in the blood. They are inside of the cells, where we have all this cellular processes going on that needs all of the repair, needs all of the NAD to fuel the maintenance processes. These things are all inside the cells. And unfortunately, NAD is too big just to freely diffuse into our cells. And to date, there's only been found that there are 2 cell types that can actually let NAD pass in, because they actually have special channels that can accommodate it. So they're big enough to let the NAD molecule in. And this is our heart cells and our neuronal cells. So our brain, neurons, things like that. The rest of the cells, which all need NAD, miss out because they literally do not have channels big enough to let NAD into them. So what this means is that you are suddenly infusing a lot of NAD into your body, but it has nowhere to go, because it can't actually get into the cells where it performs its function. And there's a similar issue with injecting it. It's also just putting it into the interstitial space, which is between cells. But the real issue is trying to actually get the NAD into the cells where it performs its function. So this is when scientists were like, okay, if this isn't the best option, then what else can we do? And this is where precursor supplements came into the story. And anyone who's heard of NAD before has probably heard of precursor supplements such as things like NMN. And all precursors they are one of the raw materials that acts as a building block in our bodies to make the bigger NAD molecule. So the idea behind using precursors to boost NAD is that if you can't get this whole big NAD molecule into the cells, why don't you give the cells the smaller ingredients or the smaller building blocks that it can pass in? And then once they're inside the cell actually sticks them together, forms the big NAD molecule, and then you've got more NAD to actually work inside the cell and perform its function. So at present, the most scientifically proven way to boost NAD is with precursors, so supplements that are orally bioavailable. And this is kind of the sort of, how would you put it, the more agreed approach amongst scientists of the best way to actually boost NAD. Because you mentioned safety as well, and I think that's important because a lot of people are, doing IVs and injections of NAD, and actually there's been one clinical study on IV NAD, and not a lot of studies at all about safety. And I don't know, have you ever done an IV or had any experience of that?
Yeah, I have a few clients and people in my network that have done IV, and they experience 2 things. One is either adverse side effects like anxiety and palpitations, but then for a day or 2, they feel really energetic and they feel amazing. They report feeling really great. So these are people in my network, but I haven't done IV. I'm a little too scared because I know the dose is really high. So I've had experience with subcutaneous injections. Very low dose, not every day, once or twice a week. And I also experience positive effects in the sense like I feel like I can concentrate for longer. I feel really productive at work and I have a lot of good energy. So can you maybe walk us through or unpack what's going on here? If the molecule is so big to not get into the cells, why do I feel like I have really good energy? And then for people who are taking those higher doses IV, how are they having those like exponential energy surges, I suppose, because they're reporting to have it? But then also what's happening when they're having these anxiety effects and these palpitations when they're getting the IVs? Because subcutaneously, I don't have those adverse side effects. It just feels really okay.
Yeah, so with an IV, you have to imagine that you are taking this high dose of NAD and you are very, very quickly infusing it into the blood space where NAD is not usually found at that high of a level. So anytime that anything suddenly changes in your body has to rapidly make a decision about how to deal with that. So in the one study that has been done on IV NAD, it was found that it seemed like the NAD was like rapidly removed from the blood. Now, it was metabolized, it seems, into its precursors. So basically, it's getting broken down into the building blocks in the blood. So if you look at what NAD is made up out of, it is nicotinamide, adenine, dinucleotide. So it's a couple of different parts. You've got a nicotinamide molecule, which is an NAD precursor, a building block. You've got a adenine, which is another part there. Then you've got nucleotides. So your body suddenly got this NAD molecule and it's like, oh my goodness, we've got to break it down. We've got to, start processing it and sending it off to different parts of the body, the liver to be metabolized, the kidneys to be excreted. So the cells will take up what bits they can, and it has to deal with it. So basically, it seems like some of the breakdown products that you're getting from NAD are affecting other parts of the body. So a key thing is that if you remember earlier, I mentioned that actually the heart is one of the only cell types, the heart cells, that actually can take up whole NAD. They have a special channel called connexin 43, which can take in NAD, but only it's down a concentration gradient. So only if something is at a higher concentration outside of the cells than it is inside, which is very unusual because, as I said, NAD is not normally found in high concentrations in the blood. The concentration gradient's usually the other way around, in that you have very high concentrations in the cells. Therefore, NAD would never usually go through these channels in this way and go into the heart. But all of a sudden, you've put a huge amount in the blood and it's sitting there and it's like, oh, well, now the concentration gradient's the other way around. The heart can start taking up all of this NAD. And we know that things like adenosine are almost can act as they're given in terms of when people have heart palpitations and things like that. So it seems to be that the huge uptake of NAD all of a sudden into the heart tissues can be why people start to feel this feeling of the heart really, anxiety and palpitations, and often feeling quite nauseous and sick. Because all of a sudden you have this huge bolus of NAD that is going places that it's in very high levels that it's not usually experiencing. So, I don't think I've found anyone yet who said they've had a pleasant experience whilst doing an NAD IV. So I think that's a really, important safety consideration when doing these IVs. The injections for sure are at lower doses. Again, what seems to be happening is the NAD is actually just getting broken down into precursors. And then it's these precursors that are actually then getting taken up by the cells and then made into NAD. So some of the positive benefits that people are getting are probably because the big NAD molecule is simply getting broken down into its building blocks, and these smaller building blocks are then being absorbed into the cells and then reformed back into NAD. But then it does kind of, bring up the argument of then why would you put such a huge high dose in as an injection or an IV when you could simply take an oral supplement, which is, a lot cheaper for most people.
I love that you break it down, the IV usage, because when I've spoken to people at clinics or experts at like health summits, they just tell me that these adverse side effects are normal. You're going to feel anxious if you do it. You're going to feel nauseous, and it's normal. And to me, it's like, that's not normal. And if it is, tell me why. What's happening in the body? And no one is able to tell me and break it down for me as to why I would feel such intense side effects if I do get the IV. So you're the first person I've met to actually break it down for us. So thank you so much for sharing that, because it's so important.
And I do think it is quite worrying, obviously with what I do, I speak to a lot of people who are promoting IVs, injections, things like that, who aren't scientists, and some of them aren't even doctors. And, it is quite worrying at their lack of knowledge about what NAD actually is, how it's actually acting in the body, because, it's not classified as a drug, but essentially it's like giving someone a drug with a terrible side effect and not being able to explain, like, this is why it's happening, which I think is a little bit worrying.
Yeah. And it makes sense now that you've explained to us why. And so coming back to the heart and the brain, you say that when we have this amount in the blood where it's not meant to be, and the molecule's so huge, so it needs to be broken down, the only place that it can be absorbed, I guess is a good word to use, is the heart and the brain. So is this first damaging to the heart and the brain, one, and two, is this the energy that people are feeling when they take the IV, but it's actually fake energy and it's harmful energy, but they're just have all this like palpitations that they feel like they can go for a run, like a marathon run, but it's actually fake energy that's really detrimental to their body and causing maybe more cortisol or more stress to the heart? Like, how would
Yeah.
you
I mean,
the difference there?
the honest answer is we're not sure because the studies have not been done. Like I say, there's only been one study done on IV NAD on a very small group of people, and to just basically try and test what happens to this NAD when you put it in, because nobody actually knows. There haven't been any studies done on the injections yet. So no one actually knows what is actually going on. NAD naturally is something that is safe. It's something that's found in every single cell in your body. It's not that you are putting something foreign into the body that the body, has never experienced before. This is a naturally occurring molecule. So, generally it is safe. But I think you also need to look at more is not always better. So that we know that NAD decreases, but actually there's a reason why it's decreasing in our body. And actually, if you want to boost NAD, maybe what you need to do is look at why it's decreasing and fix the issues that are causing it to decrease in the first place, not just simply ignore what's happening and just shove a load more NAD into the body. Because the real change that we've had in this field, certainly over the last 5 years, is that we do now understand why NAD seems to decline with age. And there are two main reasons. The first reason is that as we get older, our bodies simply start to use up more NAD. So our cells have been around for longer, they have more damage, and they have more inflammation, and these processes of repairing the damage and inflammation use up NAD. So older cells naturally have a higher requirement for NAD because they've just been around longer and they've accumulated more damage, so they need more repair. And what we also know is the second reason why NAD declines is because our cells' natural ability to make and recycle NAD in our bodies declines with age. So what most people don't realize is that NAD is not something that we get from our diets. NAD is something that our bodies naturally make themselves. So you do get B vitamins or precursors from your diet, which help to make NAD, but actually the majority of NAD in our cells is actually recycled. So we have a pathway in all of our cells called the NAD salvage pathway. And what happens is that every time a molecule of NAD is used up, it gets broken back down into its building blocks, and this recycling pathway scoops them back up, sticks them back together to form fresh NAD again. So you don't actually need anything coming from the outside. If this system is working correctly, which it does when we're young, every time NAD is used up, it's simply recycled straight back into fresh NAD again. And this is a really clever system by our body because it means that as the demand for NAD goes up, more gets recycled, so more gets made. And this is what seems to fail as we get older. And our bodies simply cannot keep up with the demand anymore. So not only do we have a situation where we've got more damage, more inflammation, and we have an increased demand for NAD, at the same time it's getting used up, but then it's not getting recycled back into fresh NAD. So this is why we start to see this decline. And one of the biggest drains that we actually have on our NAD supplies is inflammation. And we know that as we get older, a huge factor contributing to the aging process is chronic low-grade inflammation in our bodies. And this means that, whilst people hear about inflammation and think, oh, it's a good thing, because it helps to fight infection or things like that, chronic inflammation is actually a very bad thing. And this is where inflammation is sort of festering away beneath the surface, uncontrolled, and it's actually very damaging. And a real issue that this chronic inflammation causes is that it actually drains our NAD supplies. So if you were to take a young person and an older person and we were to look at their cells, what you would see is that the older people who have more low-grade chronic inflammation will have high expression of this particular enzyme on their cells called CD38. And what CD38 is it's something that drives our immune system. And older cells seem to, for no reason, have a lot more of this on their cell surface. And the link here with NAD is that this CD38 enzyme is powered by NAD. So it literally uses NAD as its fuel. So as you get older, you've got more inflammation, you've got more of this CD38, and it's draining your NAD supply. And using up NAD is then fueling further inflammation, which is damaging, which is then requiring even more NAD to fix it. So it's like a vicious circle. And I think this is really important to highlight, because if you are thinking, okay, my NAD's gone down and I'm going to fix it by only doing an IV or something like that, I'm just going to put loads more NAD into my system, but actually all of your cells are covered in this CD38 enzyme just waiting for more NAD to come, you are literally giving this, adding fuel to the fire, essentially. You are giving your cells and this CD38 more NAD, which is then driving further inflammation. So there's a huge argument now within the field that actually we shouldn't be just, using NAD IVs or injections or precursors, all things that are not actually treating the root cause of NAD decline. Because yes, you may be boosting NAD, but where is that NAD going? Is it going to repair, or is it actually going to drive in inflammation?
What's particularly important about this piece is that it's older people who are interested in NAD plus and the NAD, because they're the ones who are interested in drinking from the fountain of youth and having better energy and better skin. And they're the ones more in danger, I guess, of being highly inflamed and then fueling that fire with the NAD. And they're the ones more attracted to this longevity molecule. So it's a very important piece. And I don't think people realize that, NAD is marketed for the aging population. I don't think it's for anyone under the age of 30. So it's the 40, 50, 60, 70-year-olds, people like my mom's age, who are interested in NAD, but they're more likely to have this inflammatory, or a lot of these inflammatory markers. Would you argue that someone who's relatively healthy, someone maybe my age, I'm 37, or even someone older than me in their 50s who has a really good diet, sleeps really well, doesn't drink alcohol, manages their stress? I know we're all a little bit inflamed all the time because we're exposed to pesticides and environmental toxins and pollution, all that stuff. But would you say that maybe my inflammation, or someone who has that really relatively healthy lifestyle, my markers are relatively low and it's safe for me to do NAD? Or is there a way to test? Or someone my mom's age who's in their, maybe I shouldn't say her age, but like older than 60, maybe, you are interested in taking a longevity supplement. Is there a way to test this inflammatory marker to see if their biological environment is safe enough to take these subcutaneous injections or take these supplements?
Yeah, no, that's a really good point. And a big issue with the space is that the people that are trying to boost their NAD are thinking that they're doing something that's helpful, but actually if they have a lot of inflammation, that could actually be an issue. The answer to the first question about testing is, first of all, it's a very common question that I get asked is that, can I test my NAD levels? There's a huge emergence of a lot of different types of home testing kits now, testing all sorts of different blood markers. And certainly there are now seem to be emerging NAD at-home testing kits. But the issue is, again, that NAD is very unstable. You cannot take a blood sample, put it in the post, and hope that by the time it gets to whatever lab it's going to, that there is going to be any NAD left in there. As part of our job in the lab, we do experiments. We take people's blood with, and measure NAD. And certainly we have found that you have to literally take the blood and get it straight on dry ice and cryopreserved and extract the cells straight away if you want to have any reliable measurement of what NAD is in there before it's broken down. So whilst there are companies popping up claiming that you can send a sample away, whether that's as a vial of blood or a blood spot card or whatever. I've engaged with a lot of these companies and asked how are they getting around this issue of stability, and none of them have been able to give me a reliable answer. So I, at present, do not believe that any of them are reliable. I would love to be able to partner with a company that had a reliable test, because for us it would be great having customers that could measure it. But at present, that's not a possibility, just due to the nature of NAD. So something that we do promote people to do is as a way of trying to have a different marker, is look at a biological age test. And the particular one that we recommend is one called glycan age. Because this actually measures basically the age of your immune system. It's looking at the biological age of markers, these glycans, which are sugar molecules on your immune cells. So many people are familiar with the concept of epigenetic age, which is looking at methylation patterns on your DNA. This is slightly different in that it's looking at patterns of glycans on your immune cells. And it's very closely linked to levels of chronic inflammation that you have, in that if you have much higher levels of chronic inflammation, you're likely to get a much higher biological age, as opposed to people that have lower levels of chronic inflammation. So that can be used as a way to kind of get a reading of, where you are in terms of, not just your biological age, but the levels of inflammation across the body.
So is that good enough for someone my age, like mid to late 30s, or someone who's older, like 60 years old plus, if they have a really good biological or immune age, and it's low, the inflammation is relatively low, would you say that it's safer for those people to administer NAD+, or will you still say I guess there's always a risk, because you keep reiterating that the science just hasn't caught up with this yet?
Yeah, I think there's always a risk, and I think that's especially where for us, when I came into the NAD space, what was very obvious to me was that a lot of the NAD boosting strategies and products out there did not make sense scientifically. If as we've discussed, an NAD IV or injection it doesn't make sense scientifically because of the nature of the molecule. Precursors like NMN and NR, they are absorbed and they are formed into NAD, but they have another major issue, which is that they're not fixing the root causes of NAD decline. So they still have this issue that you boost in NAD, but if CD38 is present, we know, because CD38 has a higher affinity for NAD than the repair enzymes, that it will grab on and use the NAD before the repair enzymes even get a look in. The other thing that we know is you may have heard people talking about basically methyl issues or methyl donor issues and methyl donor depletion, where people are taking things like NMN. And the sort of science behind this is that if you are boosting NAD with something like NMN, yes, you are getting an increase in NAD inside the cells. But as mentioned, when that NAD is used, it's broken back down into the precursors, and then it needs to be recycled again. Now, that recycling pathway declines with age. So what happens is when NAD so you've got NMN coming in, it's made into NAD, great, it gets used, then it's broken down into the nicotinamide precursor. If your recycling's not working properly, this nicotinamide starts to build up in the cells. And cells don't like it when things build up. So the cell starts going, okay, why are we suddenly getting a huge amount of nicotinamide building up in our cells? We need to get rid of this. So it starts to methylate it. It increases the expression of another enzyme, which basically sticks a methyl group onto this nicotinamide and tells the cell to get rid of it. So put it down the waste route. And this is good because it stops that nicotinamide from building up. But it's also bad because methyl groups are very important for a lot of other things like DNA repair, like switching different genes on and off, our epigenetics. And it means that for a lot of people, our methyl groups start to get wasted by trying to deal with getting rid of nicotinamide because somebody's taken a huge dose of NMN. And actually, they shouldn't be getting used for that issue. So this is why a lot of, people are saying, if you're taking NMN, take something like trimethylglycine, which is a methyl donor. It's a glycine with 3 methyl groups attached to it to try and replenish some of these methyl groups that you are losing when taking NMN. But for me, it's just like, this is ridiculous, because you're taking one supplement to try and fix something. And in doing that, you're making another issue worse. And then having to take another supplement to try and fix the problem that the other supplement's causing, when really what you should be doing is just fixing the reason why NADs declined in the first place. So that's exactly what I have done a lot of research on. I've published a lot of papers on to demonstrate that actually, if you want to boost NAD levels, you just need to fix the salvage pathway. You need to get rid of inflammation and all of those things that are actually wasting NAD. And if you can do this, then you're essentially flipping the cell back to how it made all its NAD quite well when it was young, and not actually have all of these other issues that are coming up with some of these other methods of boosting NAD.
In a previous conversation, you used an amazing metaphor of a factory. I don't know if you remember.
Yes.
Because I thought it was so easy to understand, especially for the layperson. And then maybe explain to us your company and Nuchido and your supplement brand and why it helps to support this root cause process the way you're talking about it now.
Yes, I do like that metaphor. So I always say, for everyone to explain this, if you think of your cells as a factory, think of them as an NAD producing factory, okay? And if you went into that factory and production in the factory had gone down, and you were trying to go in and look what was going on and fix it, and you went into the factory and you saw that production had gone down because the machines were broken and the pipes were leaking, would you think it would be a good idea just to ignore all of that and just say, let's order some more raw material and hope that somehow we get more NAD out the other end? You'd be like, no, that is a bad idea. We need to fix the problems in the factory. We need to fix the machines. We need to repair the leaking pipes. But that is exactly what things like NMN, NAD infusions are doing. They're ignoring everything that's going on, all of the issues that are actually causing the decline in the first place. And they are simply just saying, let's just order more raw material and hope that somehow the body takes it and gets more NAD out the other end. What you really want to be doing is fixing the factory. And when I talk about the factory, I mean, you need to be fixing the salvage pathway. The salvage pathway is that recycling process in our cells that is making all our NAD when we are young very, very well. There are no issues when that salvage pathway is working well. You want to repair the leaking pipes. That is CD38. That is the drain that is just using so much of our NAD unnecessarily. You need to be inhibiting CD38 and blocking that inflammation that is just draining NAD levels. And if you fixed both of those things, technically, you don't even need any raw material. You just need to keep the process that is making our NAD in good health, basically. So this is exactly what we have studied and developed at my company, Nuchido. Is a completely different way to boost NAD. It's a dietary supplement, but we call it a second generation NAD booster because it kind of takes a very new approach that's very different from the likes of NMN. It does have a precursor in there, so it does have some raw material. We actually use nicotinamide. We don't use NMN, we don't use NR because, again, what many people don't realize is that those two molecules also don't freely diffuse through cell membranes. They also need transporters. Now, a lot of cells have them, but not all of them. And there's certainly a lot of argument over which cells have the transporter to get NMN across the membrane. But nicotinamide, on the other hand, is freely diffusible. It goes straight across the cell membrane and does not have any issue getting into any cell type. So that is why we use that one. But then we also have a lot of other different ingredients in there that are actually designed to fix the root causes of NAD decline. So when we talk about this salvage pathway, this recycling pathway in the cells, The reason that it becomes dysfunctional as we get older is because there's a key rate-limiting enzyme in that pathway called NAMPT. And basically, if NAMPT is not working, then you will not be getting an NAD recycling. And it's been found that this enzyme declines as we get older. So again, if I looked at the difference in a younger person's cells and an older person's cells, you'd see in the older person's cells that they have less NAMPT. So we have ingredients in the product that are actually designed to switch back on this enzyme. And when you switch back on this enzyme, you naturally produce more NAD because as it's being used up, it's getting recycled and it's just going round and round and your body can keep up with the demand. And we've actually done a full human double-blind placebo-controlled study and proven that using the supplement actually boosts levels of this key NAD recycling enzyme in your cells. And it's the only supplement that's been proven in humans in a human clinical study to actually do this and fix the root causes of NAD decline.
So it sounds like your supplement is not only helping to sort out the broken factory, but it's also giving some building blocks for the raw material that will go through the factory. Because it sounds like that it's inevitable that as we age, we're going to have a reduction in that enzyme you spoke about and in NAD, no matter how healthy we are, no matter if we've never been exposed to pollution or environmental toxins. It's just a natural part of life and aging, right? But let's say, we sort out our factory and the factory's working well, the pipes are working well, the salvage pathways are all healthy and well. Would it now be a good time as a 30-something-year-old or a 60-something-year-old with a strong factory to then take in NAD as a supplement or subcutaneously because my factory is working well, so I can now inject with the raw material? I still don't like the whole IV because, as you've spoken about, there are dangers associated with it, and the dose is just so high. And I'm a person that I like to err on the side of caution and not go so experimental with these huge dosage. But if there was a supplement or subcutaneous low dose, would you say, okay, we've got a good strong factory, pipes are strong, now we can bring in some raw material?
Exactly that. So two things. I think in terms of age for supplementing, certainly we know that it declines from birth, and it's better to keep on top of making sure your NAD levels stay high rather than getting low and then getting damaged and then having to replenish and repair. Prevention is definitely better than treatment. So I'd say, even in your 30s, that's when you would want to start looking at boosting NAD levels for sure. Second thing is that, I always say, I talk about the science behind IVs and injections and the limitations of it. I never say to people, don't do it. I just say, this is what the science shows us. This is what we currently know. This is what the risks may be. This is the bits that I don't think make sense. But if you are going to do IVs or injections, whatever you do, just make sure that your factory is in order first. So that when this huge amount of NAD or this huge amount of precursors arrives in that factory, at least the factory or the cells are equipped to deal with it. Make sure that you are inhibiting CD38. So again, in our product, we have a molecule in there called apigenin, which is an inhibitor of CD38. And that means that if you are just inhibiting that inflammatory process, that at least if you're boosting NAD, it's actually going where you want it to go. It's going to power in the repair enzymes. It's going to power in the sirtuins, which are key longevity molecules in our cells that actually power a lot of the beneficial pathways that lead to the beneficial outcomes of NAD. So yeah, I think just always be mindful that there's a reason why NAD's declined. And if you are going to put a huge amount of NAD back into the system, make sure that at least the factory is in full working order.
How do we make sure of that? You mentioned the biological age and the glycanage website.
Yeah.
That we can. Is there another way to make sure? Can we test for this specific inflammatory marker?
So a lot of the things that we're measuring, so, likes of this enzyme, NAMPT, they're not things that you can typically get a kit to measure. these are things that as academic scientists, we're able to really look at these unusual biomarkers. So it's not something a consumer can be doing. But this is exactly why we brought out our product, because it does fix all of these issues. It is designed to fix the factory. It has the precursor in, but it also has the ingredients in there that are boosting levels of NAMPT enzyme. It has the ingredients in there that are actually inhibiting CD38 in inflammation. It has other ingredients in there that are also actually preventing this methylation issue that we spoke about earlier. So everything that we've done with this product and tested it in our human clinical trial shows that this is actually getting your cells in order to be able to restore youthful NAD production and function. So it's all about putting the cell back into that state that it was when it was younger, where all of these methylation issues, inflammatory issues, NAD wasting issues, lack of recycling weren't happening. So it's about trying to just reset the cells so they are acting like they did when they were younger and when NAD supply wasn't as big of an issue.
I'd love to ask you a question about cancer, because as I've done some research and reading around NAD or anything related to cell health or mitochondria health or increasing energy in the cell or increasing energy or cell repair, somehow there is a risk for increasing cancer cells because we're proliferating cells or cell health. Are we also proliferating the cell growth of cancer as well? So what is there a connection between increasing NAD and like being healthier and increasing cancer risk?
Yeah. So the first thing to say is there's a lot of confusion around this, in that people somehow seem to think that perhaps NAD can cause cancer. And this is absolutely not the case. So NAD levels and cancer risk are inversely correlated, meaning that as NAD levels go down, risk of cancer goes up. And certainly if NAD was a risk of cancer, then when we're all young and have very high NAD levels, then technically we should all be getting cancer. But obviously that's not the case because it's not true. But whatever science does show is that actually NAD can be targeted as an Achilles heel in a cancer cell. And this is where the confusion has come about. And that means that basically when looking at cancer cells and when scientists are trying to develop ways to kill them, what they do is they look for things that can be targeted as an Achilles heel, things that can be removed from the cell and causing the cell to die. Now, we know that in cancer cells, they're obviously rapidly dividing, and they need a lot of energy to do this. And we know that NAD is very important in energy production. So some studies have shown that if you can starve essentially the cells of NAD, then you can actually kill them. Now, this is the same of any cell, not just a cancer cell. If you starve any cell of NAD, it will kill them. And this is not just unique to NAD. There's a lot of studies looking at if you can starve cancer cells of glucose, then you can kill them. If you can starve a cancer cell of oxygen, then you can kill it. If you can restrict any critical molecule from a cancer cell, it will kill it. And this is why there's a lot of studies looking into, is there a way we can maybe cut off the NAD supply from these cells as a way to get rid of them? But what that does not mean is that NAD causes cancer, nor should we be restricting NAD or glucose or oxygen or any other critical molecule from our cells, because our cells rely on them. It's just looking at ways in which we can target these cancer cells. Another really common one is repair. So again, a lot of anti-cancer drugs will look at targeting DNA repair as a way to kill the cancer cells. And again, this can work very nicely at killing cancer cells, but what you absolutely don't want to be doing is stopping DNA repair in the rest of your body, which is why a lot of chemotherapy drugs have some really terrible side effects, because they're never quite fully specific to cancer cells. They harm a lot of our other cells as well. So basically, the message is that NAD doesn't cause cancer. what people are looking at is, can you chop off the NAD supply to cancer cells as a way to develop a new type of cancer treatment? And that's kind of where a bit of the confusion has come about.
Okay, it's basically an essential nutrient that is needed by all cells, including our healthy cells. So we shouldn't be, having these essential nutrients or oxygen or sugar or whatever decline in general, because then we won't be healthy as humans. So
exactly that. The only caveat I'd ever say, and this, doesn't just go for NAD, this kind of goes for like any supplements, is that if you do have active cancer or you're undergoing some, treatment for, chemotherapy or treatment for an active cancer, I certainly wouldn't be taking any NAD supplements or any supplements in general, because a lot of the treatments that are designed to affect the cancer, you do not want to be taking anything else that's potentially going to interact. So my background in drug development was in cancer, so I'm quite qualified to speak on this. You wouldn't want to be taking anything that's going to be interfering with what any of these drugs are trying to do, because they're very potent. They're very specific of what pathways they're trying to inhibit. And a lot of supplements, especially, are what we call quite promiscuous, in that they interact with a lot of different pathways and they're doing a lot of different things in the body. So you've got to be very careful of interactions that may affect the outcome of any treatments or drugs.
Okay, what about your product and your supplements? Are there any contraindications that people need to know about? If people have any pre-existing conditions or ailments, or they're on any medications, or they have high blood pressure, low blood pressure, cholesterol issues, is there anything that will contraindicate or can cause adverse side effects if they decide to take your supplement, something that they need to know about before?
So there's no known contraindications. What we always say is that if someone has an active medical condition or they're taking multiple different drugs, they should obviously always consult the doctor first, to just double check. In terms of the ingredients in our products, they're already at quite high levels. So we always say, if you're taking a lot of other different supplements, just double check you're not like doubling up on any of the ingredients and going over the recommended daily allowances, particularly with like the B vitamins. So they're the sort of the general things that we tell people to kind of watch out for.
Okay, great. And lastly, I wanted to ask you about lifestyle factors. Think about in our day-to-day life, things that we eat, the way that we behave, our sleep, our stress, that can either encourage NAD production or our factory from working properly, or things that we do that obviously are detrimental to our NAD production or our recycling process.
So lifestyle's a big one. And I always say to people, get your lifestyle in order before you do any supplements or any IVs or injections or anything like that, because NAD is massively influenced by lifestyle. So if you are sedentary and you are not doing much exercise, you will naturally have lower levels of NAD, because any exercise actually boosts levels of the NAMPT enzyme and naturally leads to more NAD in our bodies. So exercise is a great way to boost NAD or destroy it. The other thing is diet. If you are eating constantly, a poor diet that's full of inflammatory factors, you are going to also be depleting NAD levels. Firstly, because inflammation depletes NAD, but secondly, actually one of the best known ways to boost NAD is fasting. So basically what happens is when our bodies go through a period of energy stress, i.e. fasting, where there's no nutrients coming in, this is sensed by an energy sensor in our cells called AMPK. And what that does is it basically sets off an alarm bell in the cells saying, oh my goodness, the cell doesn't have any nutrients coming in. We need to sort of be really careful here, where we need to preserve energy. We need to repair things and not be wasteful. And what it does is it actually, again, increases this NAD production and recycling route that elevates NAD. So first of all, we've got more NAD to create more energy to get through the energy stress period. But secondly, we have NAD to power repair, because we need to repair things rather than generate new things, because we don't have any new nutrients coming into the cells.
Oh, that's so interesting. I love that piece. What about alcohol? What about over-the-counter supplements or drugs like NSAIDs? What about smoking? It feels a bit obvious, but I'd love for you to touch on it.
So smoking, very bad, obviously. It induces a lot of DNA damage, and to repair DNA damage, we need DNA repair enzymes, and they are powered by NAD. So therefore, more DNA damage, the more NAD is going to be wasted trying to repair this damage. The other thing when it comes to DNA damage is sunburn. Sun damage is a major cause of NAD depletion in the skin. Again, for the same reason, is that it induces inflammation, it induces DNA damage, and both of these things require NAD to fix it. So again, you're going to be draining your NAD supplies. Alcohol is involved in NAD is required in the metabolism or the breakdown of alcohol. So again, one of the reasons a long time ago that NAD became quite famous is that it seemed to help with alcohol withdrawal in alcoholics. And to deal with some of the symptoms that they were going through during this withdrawal, again, makes perfect scientific sense because NAD is involved in the pathway that metabolizes and breaks down alcohol. Again, if in people that are drinking quite heavily, quite often, you always see that they have lower levels of NAD in their bodies too.
Any supplements or drugs over the counter?
Not that I know of. Not that have been studied. Maybe some anecdotal evidence, but not that we've got some solid evidence for yet.
Amazing. Dr. Nicola, thank you so much for spending time with us again here and sharing all your invaluable knowledge on NAD+ and longevity. It's been an absolute pleasure speaking with you, and I look forward to talking with you again soon in the near future, hopefully.
No, you're very welcome. Thank you so much.
Thank you for listening. Please share with family and friends that you feel could benefit from this episode, and make sure to hit that subscribe button and leave a rating and review to support the show. Check out the links below for more information about my guests and where to find them. And make sure you're following me on Instagram at wholesome_practice to learn more about what I do. I appreciate you being here, and I'll see you on the next one.